Picking up where we left off, we're going to solve for a particular variable. So in this case, we want to solve for TC. So I obviously want to get rid of this 32, so I'm going to subtract 32 from both sides, leaving me with TF minus 32 is equal to the 1.8 times TC. Then that 1.8 times TC, since it's multiplied together, we need to divide it by itself so that those cancel out. So then I can say that TC is equal to TF minus 32 divided by 1.8. Let's solve for V2 in this equation here. I want to solve V2, so I got to get rid of P2. So let's divide both sides by P2 to get rid of that P2, leaving me with V2 is equal to P1 times V1 divided by P2. Let's look at a line graph. A line graph represents the relationship between two variables. One variable will be on the y-axis, one variable will be on the x-axis. This graph represents the volume of a gas, the volume against its temperature. Its title says that it's a volume of a balloon versus temperature. It indicates that the volume is on the y-axis, the vertical axis, and it is in liters. And the horizontal or the x-axis label is the temperature in kelvins. Each point on the graph represents a volume in liters that was measured at a specific temperature. And then the line on the graph indicates that the volume of the balloon increases as the temperature increases. This is a direct relationship. We can see that as the volume goes up, 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 the temperature goes up, 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 up. So that is a direct relationship. As one increases, the other increases. This one, a nurse administers Tylenol to lower a child's fever. The graph shows the body temperature of the child plotted against the time. The temperature of the body against time. We can see that the temperature was high in the beginning, and then as time went on, the temperature got lower, 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 lower. So what is measured on the vertical axis? What is the range of values on the vertical axis? What is measured on the horizontal? And what is the range of values on the horizontal? Why don't you pause the video and see if you got the same answers. Body temperature was measured on the vertical axis. It ranged from 37 degrees Celsius to 39.8. On the horizontal was our time in minutes, and it ranged from 0 to 30 minutes. Take a minute to make sure that you understand all of the learning goals from this section. Moving on to Chapter 1, Section 5, we're going to write a number in scientific notation. Scientific notation is used to write very large or very small numbers, like the width of a human hair, which is 0.000008 meters. We can also write it as 8 times 10 to the negative 6 meters. Or the number of hairs on a human scalp, which is 100,000. That can be written as 1 times 10 to the 5th hairs. Here's how we do it. We first need to write down a coefficient. That's always part of scientific notation. Coefficient, and it's times 10 to the power of something. The coefficient is at least 1, but less than 10. So if we were to look back at this example, 0.000008, I need to put a decimal point somewhere within this unit to make it between 1 and 10. If I put it right here, it would be 0.8. That's less than 1. So my decimal point needs to go to the right of 8, because 8 is a number between 1 and 10. And then I would say times 10. If my decimal is here, I need to go back how many spots to get to the original decimal point, which is there. So I need to go back 1, 2, 3, 4, 5, 6. Negative 6, because it's going left. And on the human scalp is 100,000, so to put a new decimal point, 100,000, I would need to put my decimal point right here and say that that's 1, that's a number between 1 and 10, times 10 to the, it needs to go 1, 2, 3, 4, 5 spots to the right, which is a positive 5. Let's look at some examples. 2,400. I need to put my decimal somewhere to make that a coefficient, a number between 1 and 10. So I'm going to put it right here, 2.4. And it needs to go 1, 2, 3 spots to the right to get back to 2,400. How about this guy, 0.00086? Well, the new decimal point would need to move. If I put it right there to make it 8.6, it would need to go to the left 1, 2, 3, 4 places. Left is negative. Let's look at some powers of 10. If I wanted to write 10,000, that would be 1 times 10 to the 4th. 1,000 is 1 times 10 to the 3rd. 100 is 1 times 10 to the 2nd. Take a minute and look at these to see if these numbers make sense written in this scientific notation. We're told the diameter of the Earth is 12,800,000 meters. To put this in scientific notation, I need to put my decimal point, again, to make it a coefficient between 1 and 10. So I would put it right here in between the 1 and the 2 to make it 1.28. And then again, if I have a large number that's bigger than 1, it's going to have a positive exponent. How many spots does that decimal point need to move to get back to where it originated, which is over here? It's going to move 1, 2, 3, 4, 5, 6, 7 spots. The mass of a human? Now, 68 kilograms, it doesn't really make sense to write this in scientific notation. If anything, 68 kilograms is easier to write than 6.8 times 10 to the 1 kilograms. The diameter of a chickenpox virus is a very small number. It's a decimal point, so it's going to have a negative exponent. We would put the decimal point right here after the 3. 3 is a number between 1 and 10, and go back 1, 2, 3, 4, 5, 6, 7 spots. 3 times 10 to the negative 7. Here's some measurements written as standard numbers and in scientific notation. So the volume of gasoline used in the United States each year. Take a minute and look at these standard notations and see if you can get the scientific notations. Or look at the scientific notation and see if you can go back and get the standard number that's given. This is all really interesting information. Pause the video here. Write each of the following in scientific notation, A and B. Pause the video. Did you get 3.5 times 10 to the 3rd and 1.6 times 10 to the negative 5th? Let's look at how we can put this into our calculator. Let's say I need to put 4 times 10 to the 6th in my calculator. You're going to type in 4, and then either your calculator has EE or EXP 6. That will either give you one of these displays, 406, 4 raised to the 6th power, or 4E06. Those all mean 4 times 10 to the 6th. To type in 2.5 times 10 to the negative 4th, you would write 2.5, EE or EXP, and then you would hit the plus or minus button, 4, because we would want negative 4, and it will look one of these 3 ways. When the calculator display appears in scientific notation, now this is flip-flop from what we just looked at. If it shows us this 7.5204, that means 7.52 times 10 to the 4th, which is 75200, because that decimal point was here and it went 1, 2, 3, 4 spots to the right. Or this 5.8 times 10 to the negative 2, that decimal point would go left 1, 2 spots, so 0.058. On many scientific calculators, a number is converted to scientific notation using the appropriate keys. So you could put into your calculator 0.00052 and then hit these keys, and it will show you what that number is in scientific notation. Pause the video here. Choose the correct scientific notation for each A and B. Did you get 8 times 10 to the negative 6th and 7.2 times 10 to the 4th? Let's convert scientific notation to a standard number. Can you convert 4.3 times 10 to the 2nd power to get 430? 2.5 times 10 to the negative 5? See if you got this standard number. Why don't you pause the video here? 2.0 times 10 to the negative 2. Choose the correct standard number for that and for 1.8 times 10 to the 5th. Did you get those correct answers? Here's a concept map looking at chemistry in our lives and looking at the substances using the scientific method, how we learn, and using our math skills. This sums up our whole chapter because we just finished with converting between standard numbers and scientific notation. Do you understand writing numbers in scientific notation? And this is, again, the review of, did you meet the learning goals for this section? Do you understand this? The next slides are practice questions, where I want you to pause the video, choose the correct answer, and then I will move on to the slide with the right answer. So general chemistry is the study of The composition, properties, and reactions of matter. Pause this. Which of the following ingredients found in toothpaste is responsible for strengthening enamel? Go back and look in your notes. Should be A. Everybody's a scientist. You attempt to start your car, but it doesn't start. You suspect that the battery may be dead. Your suspicion that the battery may be dead is an example of a hypothesis. All right, that wraps up Chapter 1. Great job.